Now, you're about to hear the very first signal in human history, sent to an alien civilization. This is the famous Arecibo message. It was created in 1974 by American astronomers Frank Drake and Carl Sagan. The encrypted data contains the atomic numbers of human DNA, the location of Earth, and other information. That same year, it was transmitted from the Arecibo radio telescope in Puerto Rico, targeting the M13 globular cluster, about 25,000 light-years away. Within M13, across a diameter of about 145 light-years, there are at least 300,000 stars. According to the Copernican principle, Earth is nothing special, just a rocky planet orbiting an ordinary star in the Milky Way. If life evolved here, it could just as easily evolve elsewhere, in even more complex and diverse forms. That's why Drake, Sagan, and others believed M13 might host alien civilizations. The image you see here is the visual representation of the Arecibo message. 1,679 binary digits, arranged into 73 rows. Since the signal was transmitted as radio waves, aliens wouldn't receive a picture, but a long sequence of zeros and ones. They would need to arrange it correctly to form an image. The number 1,679 has only two prime factors, 73 and 23. If arranged as 73 by 23 or 23 by 73, only the 23 by 73 format produces a meaningful picture. The binary image is divided into 7 sections. Keycap 1 numbers 1 to 10. To show aliens, we use a decimal number system, a sign of intelligence and civilization. Keycap 2 DNA's chemical elements, representing hydrogen, carbon, nitrogen, oxygen, and phosphorus, the essential building blocks of life on Earth. Keycap 3 nucleotide structure. For lines of code describe the basic DNA structure, with chemical formulas for 12 gene-related compounds. Keycap 4 DNA double helix. The white section in the center shows the estimated number of base pairs in 1974, 4.3 billion, now updated to about 3.2 billion. Keycap 5 human figure and data. The red shape is a human silhouette. On the left, average male height at the time, 1,764 millimeters. On the right, world population in 1974, about 4.3 billion. Keycap 6 solar system diagram. Sun and 9 planets. Pluto still included in 1974, with Earth rays to indicate the origin of the signal. Keycap 7 Arecibo telescope. White section encodes the dish diameter, about 306.18 meters. And that's the full decoding of the Arecibo message. But even before it was sent, some scientists strongly opposed it, warning that revealing Earth's location could put humanity in danger. Others argued that aliens unfamiliar with Earth might not even be able to decode it. And even if the signal reached M13, was received, and got a reply, we'd have to wait 50,000 years for it to return. By then, what will humanity have become? This might be the most unsettling idea in human history, that everything about our lives was decided 13.8 billion years ago. It sounds absurd, yet it's been debated in science for nearly a century. And it all began in the 17th century. Newton, studying the motion of objects, proposed his famous laws of motion. If an object's mass, initial velocity, position, and the forces acting on it are all known, then its state at any point in the future can be predicted exactly. French astronomer Laplace took this a step further. The universe is made of countless particles, each influenced by the previous moment. So if we know the complete state of the universe at one instant, we can use physical laws to calculate the next moment, and repeat this forever. Which means, from the instant of the Big Bang 13.8 billion years ago, your choices, your breaths, even the day you die, were already written into the script of the universe. If that's true, do we really have free will? This stunned scientists of the time. Mathematically and astronomically, it was flawless. Thus, Laplace's determinism was born. He imagined an all-knowing entity in the universe, one that knows every particle's position and momentum, understands all the laws of nature, and can predict every change in the cosmos at any time. This entity became known as the Laplace's demon. In such a universe, the world is like a perfectly tuned machine. Every planet, every living being, runs according to a pre-written program. For many, this was utterly hopeless. Then, in the early 20th century, quantum mechanics began to shatter this certainty. Heisenberg's uncertainty principle showed that, in the microscopic world, a particle state cannot be measured with absolute precision. Later, chaos theory and Gödel's incompleteness theorem hinted that human behavior contains randomness and unpredictability. The hope for free will returned. Still, determinism became more complex and controversial. It forces us to rethink the nature of the universe and our place within it. Throughout science history, Newton deduced gravity from a falling apple. Maxwell predicted electromagnetic waves with just a few equations. And Laplace's determinism pushed our understanding of the cosmos to new heights. So, are humans truly unique in the universe? Perhaps only when the theory of everything is found will we glimpse the ultimate secrets of reality. Why could we, in the past, clearly see countless stars when we looked up at the night sky? Today, the stars seem to have disappeared from our view. In fact, 1/3 of the world's population can no longer see the once beautiful Milky Way. This phenomenon is called light pollution, but its harm goes far beyond simply hiding the stars. Light pollution occurs mainly in two periods. During the day, glare pollution is caused by reflections from building glass surfaces. Living or working long-term in such environments can damage eyesight. At night, artificial daylight pollution mainly occurs in cities filled with lights. As darkness falls, these numerous lights shine into the atmosphere, forming a glow that scatters and reflects, eventually illuminating the entire night sky. As a result, we cannot see stars that are distant or not bright enough. Statistics show that in 1984, the brightness of the night sky was only about 4% of the brightness of celestial objects. At that time, starlight far outshone the sky glow, which is why the stars were easily visible. Now, the sky's brightness has increased more than 1,100 times compared to 1984, completely overpowering the faint light of stars. To visualize this, imagine turning on all the lights in a room and then lighting a candle. The candle's weak glow is nearly invisible. When all the lights are turned off, however, the candlelight becomes vivid and clear. Light pollution affects our vision in much the same way. It also directly impacts astronomical observation. With the sky constantly lit, dim stars are difficult to observe. Scientists have had to build major observatories in remote high-altitude inland areas, or even launch telescopes into space. Although technological methods can reduce the impact of light pollution on astronomy, city dwellers are not so lucky. Research shows that light pollution affects the production of melatonin, a hormone that regulates sleep. Melatonin secretion is closely linked to external light levels. When city lights obscure the natural distinction between day and night, melatonin production is severely disrupted, leading to poor sleep quality. Light pollution also disrupts ecosystems. Artificial nighttime light can trick many animals into thinking it is daytime, affecting their behavior, reproduction, and migration. In Earth's vast food chain, disruption at any level can trigger a cascade of effects, causing consequences for the entire ecosystem. Since the 18th century Industrial Revolution, electricity has played a vital role in human civilization. Without it, modern urban facilities cannot function. But more than 80% of electricity today comes from non-renewable resources like coal and oil. Every 100 kilowatts of electricity consumed produces approximately 78.5 kilograms of carbon emissions. For the sake of our descendants and the future of humanity, we should promote the rational use of lighting, reduce excessive illumination, and involve more people in protecting the night sky. At the same time, we can contribute to the health of Mother Earth. This is what we call romance in the universe. At the far end of a massive molecular cloud in the constellation Monoceros, a brilliant blood red rose quietly blooms within a vast region of ionized hydrogen. This is the Rosette Nebula, NGC 2237. It lies about 5,200 light-years from Earth, spanning an astonishing 50 light-years across. Those petal-like crimson waves of gas are the glowing light of ionized hydrogen atoms. And at its heart, in the hollow blossom, lies the open star cluster NGC 2244. Here, massive stars unleash intense ultraviolet radiation and powerful stellar winds, eroding the surrounding gas and dust, sculpting the nebula into the shape of a cosmic rose. In the darkness around it, countless unborn stars still sleep in silence. Over billions of years, as the nebula evolves and flows, it will give birth to blazing young stars. Their light will illuminate this once lonely corner of the cosmos again and again. But here's something you may not imagine. A nebula is not only a cradle for stars, it is also their final resting place. In truth, everything in existence is the same. Even the atoms that make up our bodies were once part of brilliant, dying stars. It is because of them that we exist today. Across the heavens and the endless horizon, stars sparkle like scattered jewels. Star dust becomes soil, and the Milky Way is our nourishment. In the quiet of the cosmic river, the rose will bloom forever, and the romance I wish to give you, on the scale of the universe itself, is hidden here in this boundless galaxy, within a rose that will never fade. If you're fascinated by the mysteries of the universe, don't forget to like and subscribe. See you in the next video.